For our freshman design project, we decided to solve the problem of having to manually adjust your window drapes and blinds. Now, we got this inspiration from our dorm room. Honestly, every morning there was way too much light flooding into the room, and it was a struggle back and forth to see who would have to get up and manually close the blinds. This system makes it much easier. At the touch of a button, or even automatically, you can change the light in the room. So we created the auto blind system. To implement this system on our window frame, we used a variety of switches, 2 parallax servos, a photoresistor, and a battery pack to power our system.
Now I'm going to go into a more detailed explanation about how this full auto blind system works. Using the Arduino Uno, we programmed our 2 servos to open the shade and the blinds when commanded to. Using these switches, we used if statements assigned to the open, the close, and also the read light switch. These are the 3 switches I was talking about. We have our open, our close, and our read switch. The open and close are just overrides based on whether or not you just want the window open or closed. You can choose to do so. And the read switch is actually where the photoresistor is implemented. If you choose to flip that, it will read a light value and decide if the window needs to be open or closed based on the brightness.
The mechanics of our system are dictated by how the servos move. So if I press the open button, the shade will be brought up, and after it reaches the top, the blinds will also open. It will perform the same action in reverse when the close button is hit. Now let's take a closer look at the 2 servos. The servo that we have attached under our window system is also attached to the blinds at the top. As it turns, the blinds also turn, thereby closing. We also have a servo attached to the top to a wind dowel rod. As it spins, the shade will close.
Looking at the back of our system, you see that the photoresistor faces outward towards sunlight. That way it can read sunlight values, take that into the Arduino, and make a decision from there. Operation is performed when the read light switch is flipped. If I were to flip this right now, it reads that there's too much light coming in, so the window will not open. However, if I were to cover the photoresistor with my hand to represent a cloudy day, and I were to flip this, it reads that light levels are lower and it wouldn't be too bright to open the window.
In this case, if our system is already open, we can still use the photoresistor to read a light value to make a decision. Covering the photoresistor with my hand to represent a cloudy day, we can still use our photoresistor to read light values. So if the window is open, it will stay open because there's not enough light to make a decision to close. On the other hand, if I remove my hand, the photoresistor reads that there is too much light flooding in, thereby closing the system. The concentrations of engineering that are incorporated into this project are both mechanical and electrical.
Mechanical engineering came into play when considering the best way to make a servo roll up a curtain and also use another servo to switch the angle of the blinds. To do this, we had to create a special adapter made just for these blinds. Also, we used the dowel rod, which we made an attachment for to the servo to be able to roll the curtain up. The concepts of electrical engineering were used when wiring our switches, servos, photoresistor, and programming all of these parts to implement with the Arduino system. Throughout this design process, one of the biggest lessons we learned was to never throw out an idea. Looking at our final prototype and comparing it to our first concept that we thought we were going to stick with, many features have changed. For example, we thought we were going to be able to use a pulley system to draw the curtain up rather than a dowel rod on a spinning servo.
This project truly taught us how to innovate through difficult circumstances.